Everybody, I'm Pieter from Schalkwyk, and I've got Gavin Green here with me. We're going to take you through our first interactive session with our multi-agent agents that you can ask any question. We've had a number of questions, and you'll see on Gavin's screen there were some questions that came in from the people that registered. So thank you for all those questions. It's good. It's the first time that we do this, so it's going to be really interesting to see what the outcome is. We have no idea how this is going to answer. It is fully generative. Gavin will run you through the process that we are going to follow. If you do have any additional questions, please type those questions into the chat. We'll also try and incorporate those. And again, Gavin will run you through the process. I see there's already a question around will the participants just quickly get a recording of the webinar? Yes, absolutely. So everyone who's been registered will get a recording. There's also, you'll see the answers we're going to publish, and you'll have access to those answers as well. So with that, I'll hand over to Gavin. And you can explain the process and kind of all the moving parts before we go into and start doing this.
Thank you, Pieter, and thank you, everybody, and thank you for the questions. So I've got on the screen here just a bunch of questions that we have, as well as some of the user questions that we're going to go through and answer them. But before we do that, let me just give you some context as to where is this all going to fit in and where does this all sit in. If I go to our app designer here, which is what I've got open, and I just go into a example that I've got here. This is stock standard XMPro pieces, and I just want to paint a picture of where does the agents fit into this, just so that you understand the context of that, and then we will dive into the questions and the code itself. So this is a use case around substation. On the right here, you have the first area of where the agents comes into play. So you've got your assistants, your experts, your advisors, etc. If I drill a bit further down, down here is where we can actually see, again, more of that assistant and advisor. So you're seeing the result. You're seeing the end result of the deployment of these particular agents themselves inside the XMPro environment. These are views that make sense to end users like you and myself. If I go to a different view here is where does the agentic side come into play, which is what I've got open here. This is a team of agents that we created around a particular business problem. So there's a concept in here called objective functions. What's the objective of the team? Everything that we create is around optimizing those objectives. Is the team performing? Is the agent performing? Etc. There are 3 agents deployed in this. So you've got environment load, and each of them has their own objective function. Each of them has their own memory cycle. So you're looking at the 3 here. This is where the observations comes in. You can see reflections are happening as we're busy working through this as well. This is live. This is running. So these agents are deployed and are busy executing in our data streams to get the data, move the data, etc. So again, this is the result. This is the result of the agents doing what they're doing, running through their memory cycles, running through their calculations. Communication with each other happens in here as well. What we're going to be doing is we're going to be taking these questions and we're going to go into the actual source code for this. This is Visual Studio Code. This is Klein. But before we do that, this is the actual source code that is sitting behind those agents.
Sorry, Gavin, to interrupt. I just want to emphasize this is just this one specific module, the Multi-Agent Generative Systems module in our source code. So it's not the digital twin code or anything like that. This is just the MAGS code.
Yeah. So this is just the code that is sitting behind this, sitting behind this, and sitting behind this. To do the bits and pieces. This is not the code for the entire app designer. This is not the code for the data streams or anything of that it is really just the code for the multi-agent generative item itself. If I go into it, and I'm not going to go through all the source code in here, but it is broken up into the different areas. So the agent with their actions, the communication layer, everything is done through abstraction and factory. The consensus piece, the content, the core pieces. So you'll see things and can ask questions around, well, how do you do confidence, objective functions, the recency scores, all the data layer pieces sitting there, all the embeddings with their providers, the graph with their details, the large language model, metrics, telemetry, the planning. So optimization and strategy from a planning perspective. These agents, we call them cognitive agents. They have the ability to observe, reflect, plan, and act. And this is all the business logic that is implemented to facilitate that. The telemetry, all the tools, we expose our data streams as tools to the agents themselves. And this is the mechanism that allows that, all the utility functions, and then obviously the vector pieces in it as well. So this is the raw source code. And what I could do in the client piece here is I can start asking it the questions for it. So the questions that we've got in here are broken up into different areas, as you can see on the right. So we've got some architecture, some memory, some capability, some planning. So we're going to go through these. We'll have some of our own in there, but the intention is to go through all of yours and answer all of your questions as we do the pieces for this as well. Right across the top, generally what we do in here is we'll just copy that. We'll just paste that into the client interface. This is running a Sonnet 4 at the back. You can change this and run whatever model it is that you're looking to do here. This is the one that we use to answer these particular questions here. And what this is going to do is this is going to start taking my question, interrogating the source code, and start answering the question and interacting with me as well. Across the top, it is starting to work through its tokens. So top right, you will see what's this going to cost me to ask these questions, interact with these questions as well. What it's doing is it's going through all the actual code that you're looking at. Based on the question, it understands the context. It knows the structure of that source control, and it is going through to get all to the pieces that it needs to answer the questions that I'm asking it. There's a lot of different questions in a lot of different areas for different concepts, starting with architecture, going into planning, etc. So the first question I asked it is just to explain the overall architecture. So what are the main purposes? How do they integrate? What's the system's primary purpose? So the code in here is designed for a single agent. So this code that I've got in here is not for all agents. We deploy multiples of this to answer the multi-agent piece. And that comes into the data streams, and I'll show you what that looks like as we progress into this. We use our data stream for tools. We also use it as the layer where these agents run and where they execute for it, which means we can control very granular what information goes to it, as well as what to do with the results coming out of it. So the overall architecture, you've got an agent core, there's a memory cycle, which, as I mentioned, is an observe, reflect, plan, and act. There's the planning system. Everything goes through communication infrastructure. So there's a message broker layer, which allows us to plug into things like MQTT, AMQP, DDS, etc., etc. There's a consensus system in here. How do we get consensus between different agents? So again, if I come back to what is it we're looking at? We're looking at one of each of these, which is running. Each of these is responsible for different items. They're responsible for different objectives. However, they will have competing objectives. When you have competing objectives, how do you get to a stage where you can get to a result that's to the benefit of the team? So that is where the area of consensus comes into place. The tool system, this is how we expose tools to the agents. Again, the primary one for us is using our data streams. So any data stream that has been configured by any customer or partner, with the addition of 2 extra blocks you drag on to the end, it's available for use by the agents as well. Data management context.
So, Gavin, just being able to use our data streams allows us to create a kind of a multi-step tool. So you can create quite a sophisticated workflow as a tool in all of this. So maybe if you want to grab this and put it into.
So what we're going to do with all of these is I have another project which is up here, and what we are going to do is we're going to post the question, and then we will actually post the, if I can spell, there we are. So down the bottom here, I can actually take all of this, we'll copy that out, and we'll post the answer in here for it as well. So the intention is to check this in. This is a public repo. I will make the link available in the chat towards the end, where all the questions will be and all the answers will come into the area for this as well. So we'll save that from the architecture side. So first question was, I'll explain the overall architecture. It's also got some different types. The key piece here is the different interactions. What's the cognitive loop it runs through? What is the communication flow consensus? You can also ask it to give you diagrams, mermaid diagrams, etc. as you go through that. That's the first one right at the top. If we go down to,
sorry, maybe Gavin, just thinking on the fly, because this is a completely on the fly thing. Maybe ask it, explain, observe, reflect, plan, and act. Because I think that's a key part. So what we saw on the screen is that these agents observe, reflect, plan, and act, and there's a different GitHub repository as well, which we'll share for some information on kind of what that. But we just really want to know what it does inside. And again, this is interrogating the source code. So it's looking at the source code itself in terms of what it does. Again, this is completely generative, so we have no idea what it's going to come up with as we ask these questions. So there's an interesting part. So just go back there, Gavin. One of the things is on the reflection, there's a significance score. So it really looks at how important is this data, that new data that came in. So there's a combination of importance, surprise, recency, decay factor. Like humans, these things forget. So there's some really interesting things that we do inside that part of, we call it the memory cycle. So again, it then has the planning phase as well as creating actions and tool usage. So
so the plans have different strategies that's implemented. We tend to output most of them in PDDL. And inside our data streams, there's a data stream integration component, which allows us to actually take that apart and use it. So if I look down the bottom here, observe, there's a significance check that will drive the reflection. Do we need any planning? So there's planning triggers, plan, act, and then we keep going on from there to do it. Different examples in here as well. So if I go down to the bottom here, I'll come back to the top question. So what's the difference between the solution? So let's copy that out. And let's
you also want to select the previous one and add it to the other GitHub.
Yes, I will do that as well.
So that we don't lose track of it.
Pop that into here. Bottom. I'm going to have to clean this up as we go. So we'll copy this out and paste it into there. So different question. This is one of the user questions. What's the difference between our solution and Crew AI or LangChain as well? So we'll ask it to do that as well. One thing I should mention is there is no preceded information in here, preceded context. The only context it has is our source code. whatever is in the Anthropic Sonnet 4. This is using the 1 million token, and whatever it has access to from the internet, and it'll tell us if it actually uses the internet to come up with any of the pieces there. So the question here is trying to understand and articulate what is the difference between the agents and mags as we have it here versus the Crew AI, the lang chains for it. So the philosophy, having each agent having its own cycle, industrial first. So everything we do has a industrial focus in mind. So how does it scale? How does this deploy into heavy industrial environments and can scale with the needs? Interestingly, Crew task-oriented, workflow-focused, and then LangChain bring a framework and a toolkit for it. So memory and learning systems, current task and sessions.
Yeah, so we've created a very significant graph at the back that is basically a shared knowledge space and a shared decision space. So every single action, everything that the agents do gets logged in a graph at the back, because we need full transparency, full auditability, and also create significant audit at the end, being able to explain and we can also create synthetic memories in that world by creating experiences in a simulated environment as well. So
put that answer in there. If I go back in here, and I'm just going to do a search at the top there for lang chain, lang graph. There's no preceded anything in here to help influence its questions, to help influence any of the details. There are some context decisions. All of these are blank. There's nothing in them to influence the decision. So we're getting this as raw as it comes from the actual source code itself.
So if we can just look at the last sentence there, just as a quick comparison, just to finish that. So it's not a framework or a workflow orchestrator, but cognitive architecture. Yeah, that's been our objective, is to create a thinking machine, emulating human cognitive behavior in the way that, and that's why it's got that observe, reflect, plan, and act that each agent does. And they can work collaboratively through communication brokers and things, rather than have a sequential fixed workflow. We have 5 agents in a row they work towards objective functions. Cool.
That's the key piece for me out of it. The needing to operate continuously in complex operational environments where you can't determine your flows, you can't determine the paths out front. Now, this is not a, either or. Each of them has their place, which is what the summary gives quite nicely at the end there as well.
And I think this does relate to a question that came in that said, who is your biggest competitor in the mag space? When we look at, in terms of our approach to mags, which is a cognitive agent, research analysts, industrial analysts, and I'm not going to name names, at the moment, says in terms of the cognitive agent, we are the only ones that have built that. In terms of agent, multi-agent, there's Auto-Agent by Microsoft, there's Crew AI, LangChain, there's a whole bunch of them. But they are more content curation and creation multi-agents. So you have 5 agents. The one is a writer, the other one is an editor, the other one, and they sequentially work together. So in terms of how we approach it, right now we're pretty unique in the market. But in terms of the overall mags market, yes, there are a number of players in that. Our focus again is how do we solve. So the problem that we're seeking to solve with this is industrial systems are getting really, really complex with lots and lots of multivariate challenges. So how can we optimize an industrial decision-making process with the fact that there's a challenge around skills, we're not trying to replace people with this. In the average retention rate of a new hire in manufacturing industry in the US is 50%. 50% for the 90-day retention rate. 50% of the people that you hire will leave in the first 90 days. There's a skills challenge in industrials. So that's what we're trying to address with this. And that's why we've built this cognitive approach rather than just another workflow. We, by the way, in our data streams with the LLMs, we build those same kind of more sequential workflows, but MAGS is specifically designed around this cognitive cycle or the brain kind of approach. So, Gavin, you asked a bunch of questions there. Yes.
There's a question that came in on the chat there. Can this run on premise? The short answer is it was designed that way from the beginning. So yes, it can run on premise. With regards to what the stack is that it needs to integrate and use, all of that can be cloud deployed, on premise deployed as well. From an LLM perspective, it's a bring your own large language model. Whether it's a core foundation model, whether you're fine tuning or both, you can use local model inferencing, you can use private clouds, you can use public clouds if you really want to as well. Message broker and the on-premise pieces is data streams. Yes, data streams are also designed and architected to run on-premise. So you can run fully air-gapped, you can run as a hybrid, you can run as a private cloud for all the different pieces there to do that.
There's actually another question that came in, which we can maybe quickly put in there. What kind of quality assurance do these MAGS workflow offer? LLMs hallucinate. So we have no idea. And this literally came in from someone who posted this 2 minutes ago.
Okay, so
we have humans in the loop. Or is humans needed to make sure that this is reasonable? While this is answering that, and Gavin, maybe you want to copy those previous answers into the other repository before we forget. So while this is generating, so yes, you'll see we can run through how we handle confidence scoring and a number of those other mechanisms to do this. But the way that we address hallucinations, just at a really high level, is we have an objective function, and we can ask the source code in a second what objective functions are. But we have a mathematical objective function which the teams need to optimize towards, either minimize or maximize and get to that. So every single team works to a mathematical objective. We can very quickly team with, and it's a very deterministic number. It's a KPI almost. These teams are much better than humans to tell us whether they're achieving their KPIs or not. So as soon as we digress or can diverge from the objective we set for them, we can know immediately and look, are there hallucinations? Is the data wrong? Because there might be a whole number of problems. Hallucinations are less and less of a problem these days, and also we choose our agents very narrow. But let's see what the...
Okay, that's it. So question was, what kind of quality assurances do them LLMs can hallucinate? Is human needed? So the first is we have a scoring mechanism that comes in for it. So all memories are created with a confidence score. So you'll see here is an important score, here's a surprise score. There is also a confidence score, which is internal to the agents as they are generating these. How confident were they in what they were generating?
The load optimization agent reflection, Gavin, you'll see actually there's a confidence rate.
Yeah, 7 out of 10. So there is a mechanism to actually bring that in and let it do that. If we continue on, there's confidence-based gates. There's memory validation, so memory significance scoring. So how important is it? Surprise, trust, consistency, cross-memory validation as well. Everything is stored in a vector database for memories as well as a graph database as well. Consensus mechanism for critical decisions, the triggers, and then you've also got the human in the loop as well. So you just want to do level 1 monitoring? Do you need certain approval at certain levels? Or do you need the human to help you with collaboration in there as well? all actions, if you remember, we've got observe, reflect, plan, and act. All actions, when you define them, also have preconditions as well, and those are also checked and validated. There are safety critical actions, so you can classify actions as are they safety critical or not, and that gets worked into objective function alignment. And that's a key piece that we mentioned early. To do that is to bring the objectives in. It's one thing to deploy 1,000 agents. Question is, they need to do something. And when they're doing something, how do you make sure that they're doing the correct thing and that you're getting value from them? For us, that's where the objective function comes in, working towards an objective and being able to measure it as well. Real-time monitoring, validation through integration, different autonomy levels, error recovery and rollback, and decision audit trail. Everything, to Pieter's point, everything that we do is stored in the graph. So the graph database holds everything. All memories are vectorized and stored in the vector database in conjunction with other RAG documentation as well. The regulatory and compliance piece, where that is coming in from, is the agent profiles, as well as the agent instances when you set them up to be able to do that as well. So good question coming in there. Hold on, let me copy that answer out as well. Paste that in here.
Question. Let's go to some of the earlier questions that we received. There are some more questions coming in. Is RAG being performed? What is your pricing model? That we're not going to ask Claude. You can contact either Gavin, myself, or one of ourselves. But the current model is a fixed price, and basically build as many themes as you want. That's the current model. It may change, but yeah. So happy to go through that. So let's take some of the initial questions that came in, and then we can also address some of the ones that are coming in online.
So we touched the bottom one. This one here. What are the most impactful problems, and how can we jumpstart our ability to solve these two? So what we've done is, again, this is the result that you're looking at here. So this team was created, agents were created, profiles, tools, actions. How was that all done? And how did we decide which one of these gets us to that point? We created a particular wizard. So this is the actual wizard for MAG's business cases. And what this does is it walks you through a series of interactive, conversational style to validate the suitability of your use cases. It helps you generate the problem, work out the business value estimation pieces. The team overview goes all the way down. There's the objective function, and then generates all the JSON pieces for you to automatically create these teams, to create the tools, everything else. So this is how you can set the wizard up. We've set that particular wizard up, and this is an example of us running through the pieces here. So we've gone through all the different steps here. On the right, I can see the summary. So is it suitable? I can see the business problem piece, the planning, how do we want to get to? And I can go back to these at any stage that I want to and have a conversation with it as well. When you go into each of these, there is a prompt that sits at the top, and there's a how do you want it to handle conversations, etc. So you can configure all of this to your own requirements. And that is what we use to work out how do we jumpstart and how do we get people to firstly identify, is this a good use case to use the MAGs for it? Or is this a deterministic workflow? Or is it a combination of the both? Or is it not a fit in area at all? So that's why I've got it tagged as the wizard piece there. Agent capabilities. So this is a question very similar to the other one around the quality assurance, so safeguards. So we'll copy that specific question out there, and we'll just keep it going in the same thread here as well. What this is doing at the top is this entire conversation has cost 78 cents for us to do this as it stands right now. The tokens that we're using, the different steps that it's going through, for the pieces that we've got in here, and now we're asking it for decision making in it. So from the data stream perspective to the dynamic, the plans, the real-time safeguards, the different circuit breakers that are in it as well, impact, performance monitoring, and some human oversight pieces coming in, etc. as well.
Gavin, sorry, if you just go back to the question part.
So the question that I put in there is, how does it support real-time decision-making in dynamic commercial, and what safeguards are built in as well?
Just quickly look at kind of how do we support real-time?
Scalability, so real-time collaboration. So you've got the human pieces in there as well, human oversight, dynamic pricing, because we had a pricing question come in, real-time performance metrics, dynamic consensus for critical decisions as well. So real-time validation gates, so safeguards, commercial environment.
So can I ask you to say, please provide a summary of this for a business user? Because that's a lot of work. We'll put that answer in. I see one of the things I mentioned there is a sub-second response. Yes, we can monitor things in sub-second. LLMs can't respond in sub-second. So the data streams can handle sub-second. But the LLMs itself, as you see, it takes time. Even with this, there's a response time. So for when it thinks, when it does. 10 seconds, 50 seconds.
There was another question that came in as well around how do we pick models, decide which models to use, etc. Sonnet 4 likes to put everything in an implementation approach and how we do things. So that's why you get how do you start from a pilot? Start low risk, build human oversight to build trust, and measurable KPIs and ROI. This is the key starting point. I know there's additional question that is a bit later, but this is a key starting point here for people, is to build trust in what we're doing and what we're doing. Okay, so I'll put that question in, answer in as well. So question here. So we're going to be moving into agent capabilities. So what I'm going to do is let us start a new one, and we're just going to ask it that question out the gate. And while that's busy, we're going to create a new file in here, and this is going to be called agent capabilities.
And you'll remember to put those previous two in as well.
Yeah.
Okay, there's a question on does XMPro have predefined models developed for industry-specific, like power, or can we develop our own AI models and use AI agents from? So one of the things, and maybe Gavin, we just show a data. Well, we can get back to that question in a second, because this one has actually come up with an answer, but we will show you how we do that before specific.
So based on the analysis, so the question, how do you handle agent failure in production? So global exception handling, centralized error tracking, agent status monitoring. So agents give their own status. There's metrics, telemetry, periodic status update. The message broker has failure mechanisms built into it as well. The agent instance management handles failures during initialization with proper error messages that bubble all the way up into the exception at the top. Everything is built from the ground up with telemetry and observability. So we implement open telemetry, which means you can output the configuration to an open telemetry compatible endpoint and consume all the traces, logs, and metrics as well for it as well. Automatic restarts, monitoring and alerting resource multiple brokers are supported as well. So copy that out and put that into this answer here as well. So how do agents work in, oh, I like this one, Daniel. You have a value system.
So agents have a value system. This is literally the question that came in. So no,
Yeah, we only corrected the spelling of the word XMPro. Everything else is as we got the error of the questions that came in. So we'll just paste them in and ask the question in here as well. So the question was, does the agent have a value system in it as well? So you can see it knows about the source going straight into the objective function pieces, responsibilities, constraint, values, ethics, morals are being brought out as well. So those are coming in. There's the confidence calculation coming in there as well for all the pieces. So what it's built around is those objective functions we mentioned earlier, as well as the confidence-based decision-making. So how confident are you in the decision-making as well to do that as well. So objective functions is the key, agent constraints and responsibility. This also touches a bit on some of the questions we had around hallucinations and how do you constrain. So objective functions is one. All agents have explicit value boundaries, so they have responsibilities, constraint, safety considerations as well. So you define them to be very specific and not generalists. There is also confidence assessment, so we're factoring in the 5 you've got there. Objective functions, trust factors, so planning and decision making. So all decisions are evaluated against objective functions. That's a core piece for us to do what we're doing. Higher confidence is given to decisions with certain values. So again, what are those values at the top here? You have these responsibilities, constraints, safety considerations. The area of deontics as well comes into this to do that. There is a lot of feedback loops for it. And because we are persisting and storing all the memories as vectorized, they're available to the agents. And that's also the area where we start bringing in things like synthetic memories as well to be able to do this. So so we're going to ask that question. While it's busy with that, let me go and make sure I paste this question in over here. And we'll go grab the answer, and then I will go have a look at the synthetic memory. Okay, so how does synthetic memories work with this? So they're provided by expert validated experiences. So they've got a pre-validated alignment, scenario, category, and they are factored into the confidence. Now, why would we want synthetic memories? There are situations where you can't actually get to an event or an outcome without catastrophic failure, destroying something, or too costly. You know what the expectation and the outcome should be given a certain scenario. So you can create synthetic memories, which helps the actual agent as they are pulling different memories back in as well to be able to do that. So confidence, value, so safety critical. So you can preload them with safety and responses. So you do not have to wait for those events to occur before you can actually give them the expected response and the expected behavior for it as well. The last three here are compliance, best practice, propagation. How do you make sure that they behave and give you the outcomes that you're looking for as well? So almost a reinforcement aspect, and then also the ethical pieces as well. Last one I want to put in here is what is Deontics?
So not everyone might be familiar with the concept of deontic logic. So let's see what. That's one of the things that we built in as part of the safety and obligations and value system in a way. So deontics is a key part. Gavin, I think after this, maybe we go back to some of the questions that we got in live, just to kind of have a bit of a mix of questions. Okay. I see there's one RAG, and there's one around predefined models, and there's a question around real-life use cases. Yep, we have them in mining, oil and gas, and water utilities. The level of sophistication differs. But again, we can't ask client about that, so I'll just answer those. And can users set up the confidence intervals around that? So again, if any sales-related questions, happy for Gavin, myself, or anyone on the sales team to engage with you on that.
So the deontics is the obligation, permission, and prohibition, which is what we're currently working with. It's an area of study. It's a field to be able to do that. So there's deontic tokens, token management, and then it's implemented into the core pieces to be able to do that for communication governance, action authorization. Are you allowed to take that action? Are you allowed to communicate and to make sure that everything is compliant and auditable as well?
Maybe share agent profile configuration, Gavin, just where all these talking about, where does it actually end up?
Yeah.
When you configure this, we talk about deontics and all these things that you configure. So where would that all live?
So if I go into this example here, which is the profiles. So everything for us starts at a profile. So here from the profile this is a load optimization profile. There's the system prompt, skills, experience. Here is where we start bringing in those deontics, the organizational rules as well. There were some questions on RAG and how does that work. This is where you configure the RAG pieces. So does this particular profile have access to particular RAG? Does it have access to the general RAG as well? So you can pick and choose how you want to set this up. This is also where you set up some of the memory settings. So your reflection threshold, we do want them to forget, just not as quick as we do. So hence the decay, how many memories, cache, etc. What reasoning framework do you want them to use? And then the observation prompts and reflection prompts. On the right is where you can bring your own provider and bring your own model in here as well. Every profile can run a different model. So if you want to use everything on one foundation model and just use it, you can. You can mix and match different agents to different models as well, even fine-tune models in here. So it starts with a profile. This is where you see the deontics and all the different pieces. Then what happens is you create a team. Now the wizards will create the teams for you. This is how you can go and manage the teams afterwards. So the team that I've got is this one here. Down the bottom, any compliance requirements the team has to adhere to, the objectives of the team, the objective function for the team. This is where you define that as well. And then you've got the instances. So each of these instances is off a particular profile. This is where you allocate them their tools they're allowed to use. So this is how you can configure and change the behavior of the different agents themselves. Do they have any constraints, responsibilities, the user prompt, task prompt, and the objective function for that particular agent as well. So it's all configurable. I think the word is parametric.
Yeah, I just wanted to say, so you're not writing any Python code in here. You, as a subject matter expert, you can configure these in a parametric approach. So parameters, So everything is parameter driven, and it handles the logic kind of at the back. Maybe, Gavin, let's get to maybe is RAG performed in the background when asking? So one of the questions online. If you
let's do that.
I'm not sure we're going to get through all the questions, but looks like
so let's ask it.
We have to create a part 2 of this. So again, it's now looking at the source code, as you can see, for how we've implemented this.
So yeah, the reason I broke all the questions up into certain areas is context is important when asking questions to an LLM. That's why we spend a lot of time creating that framework around the profiles, etc. And it's just as important when you're asking questions here to get the correct answers that you're looking at, is to make sure your context is correct. So the prior pieces in the conversation, if they're related to the question, I don't mind putting them in. But if they're not, it's best to start from the scratch piece, as I did here. So is it being performed in the background? So yes, it is being performed. From the abstract level, there's the general RAG side of things. There's also agent-specific RAG per profile. So the configuration you saw me use for that, as well as we use memories for RAG as well. So it's not just what documentation you load up. We also use memories for RAG in here as well. There's a central mechanism to be able to do that. It's handled and used throughout the conversational processing piece, content processing, memory operations, planning, and decision. So pretty much all the key pieces for us. It's used for all of those. You can decide from an agent perspective whether you want to allow them to use general RAG for it. You can specify a particular collection for each agent themselves. You can also define the top number to bring back. So if you come back into here and we go back to the profile, you'll see all the RAG configuration pieces coming in here. So I'll just go to the top one here. So top how many, which, and what is my embeddings that I'm interested in doing as well to bring that in. Whenever we use RAG, and it is applicable to be provided to a human, then you start getting citations and formatting that come in as well to be able to do that. So
cool. There's a question around, can the user set up the confidence intervals? Or is it predefined and fixed to it?
So the users have everything here from the memory settings, etc. The confidence levels are, you can configure them and change them to be able to do that. So all the important scorings, the surprise scorings, the confidence scorings, the retrieval, etc. You can change and tweak those. What we tend to find is the area that most people get the best out of the agents is adapting and changing the prompts from the profile side and adapting and changing the details from the team side versus going down to trying to understand and unpack the confidence intervals, etc. But you can change it. We made everything parameter driven to facilitate that, but we also made it so here's some pre-defaults when it's set up, because we're also not everyone's going to go to the nitty-gritty detail to go and make the changes and dig into it for it.
Okay. Let's go to some of the questions that we got in earlier, and then I think there's one or two. There's a question around how would we characterize applications situations where MAGs is the right approach. We could get to that one towards the end.
Around consensus. So the consensus piece in here as well. So we talked around RAG. I can keep consensus in here.
So just on consensus, when you've got 5 agents that each have their own objective function, plus you have a team that has got objective functions, they're not going to agree all the time. So you need to find a way to actually have consensus. And that is probably one of the harder challenges we had in the whole configuration of MAGs. It's not the agent or coming up with what they need to do. It's how do they agree as a team on what are the consensus structures. Maybe Gavin, a diagram or something would be easier. But you can explain.
Yeah, so I'll let it do its thing here. So the specific question here is around auditing and logging the consensus for debugging. So everything goes through that open telemetry, as I mentioned. Everything goes through structured logging as well. Everything is output through the message broker. So all consensus are stored with their full metadata in the graph, and the message broker layer will give you everything to view it. All rounds are auditable. The plans are auditable as well. As you go through the progress, you can see the different levels and different areas that it can actually go into for its integration points for monitoring, message broker, telemetry. So this is all on debugging. So explain to me consensus and what the So the first question was very specific around the let's go here, around the audit and the logging piece. But what I've asked it to do now is just to explain to me, well, what is consensus? How does it work, and the different pieces that it goes through. So it's a collaborative decision-making process, as Pieter mentioned, to be able to reach an agreement on a shared plan or decision. So instead of having one agent make everything unilaterally, is how do they work together towards a common goal? You might find that in a team, one agent actually has to perform a little bit worse to the betterment of the actual team itself, which is counterintuitive to, well, I need to be the best that I can be as well. So you need a mechanism of consensus, which is what I highlight over here. There's a trigger, but then it gets initiated, invitations get sent out, the process gets started, plans get drafted and shared, there's conflict detection, resolution, and the final outcome is either we reach consensus or a human intervention is required, and timeout as well. And then there is also formal voting if you want to go into the formal voting pieces as well. So when is consensus triggered? Initiation, the draft plan. Okay, drew some pretty nice diagrams. None of this is preceded information and results that we're getting here. So this is raw, straight out of the actual code itself. So I'll copy all these out just after as well.
Let's quickly see on some of towards the end, user questions that came in, and then we'll address one or two. We've got 5 minutes left.
Okay. I know there's a few questions.
That's one.
So let's actually pop this one in. Again, just going to pop that in and have a see what it thinks about that against the actual source code. So where this is all going to go while that is busy is it is going to end up in a public GitHub repo for all the questions and the answers. Let me copy that link there. And there we are. I just put that in.
There's a question around, can you give an example, agentic AI used effectively in manufacturing? Golden batch optimization in process industry is a great one. These agents are really good at optimizing, planning, scheduling, taking a lot of information, multivariate, and the golden batch is one that we've seen is really good. Any predictive maintenance as part of a broader operations team, OEE, but OEE is such a broad concept, so we like to create focused teams around certain OEE capabilities, looking at reciprocating compressor health. You can get down right to kind of a task based around specific equipment or optimizing process. What we like to also add into that is kind of safety agent, generally looking at safety aspects as part of a broader team with a specific objective around that. So, Gavin, there's another one that says, would you characterize maybe that longer one, which says, would you characterize application situations? Again, I'm just mindful of time.
Is the right approach with a high level innovation, or where MAGs is overqualified?
So maybe just, so yeah, we support a large range of models, and we'll continue to support more of them. In terms of the actual choosing the model, quite often we don't have the luxury of having 13 models in an organization. An organization would typically choose one. It's more, which flavor of it do you run? Do you run like this one that's very verbose, or can you get away with a 7 billion parameter model running at the edge? So it's pretty much determined by the use case and the application. That we do provide some guidance on it, but at the moment, you often find in the organization they choose a certain environment and then they kind of stick with that. There's a thing around business value estimation, the suitability of the use case to that other one around that. How do we decide? So we have a prompt that runs in this wizard that actually looks at the suitability of this. So this is for stereo tanks, and you'll see in this one that was the business problem, and then this is highly suitable, and it breaks it down why in terms of for this application, is it? But yeah, this is not a deterministic system. If you want a deterministic workflow, we do that in the data stream. We can embed LLMs in that. If you want something, sorry, Gavin, if you just go back to that wizard very quickly, you'll see in step 3 is a business value estimation. We also do kind of what's the business value of this as well as part of it. And again, you can fine tune the prompts at the back of that to suit your organization. One last thing I'd like to do before we close, Gavin, there's a slide. I said we're not going to show any slides, and this is actually where the agents run. But if you could I just want to highlight one thing, and we didn't get, and we'll run these other questions that we didn't get to. User questions, we'll run it through Klein and post it in that same GitHub repository. But what we found in building this, and you'll see there's 30,000 lines of code just in the MAGs module. That's not comments or things like that. That's actual executing code. 8% of that is around the LLM. 92% of it is building consensus, communication, objective functions, and we didn't even get to touch on some of those capabilities in this. So hopefully it's been insightful in terms of how this works and what all the moving parts are in making something like this work. And if there's interest, we would be happy to do something like this going forward.
Thank you all. Have a great rest of the day wherever you are.